So I had 12 individuals rate math on a scale from 1 to 10. What we're going to do is we're going to take all of their scores and we're going to figure out a few different ways that we can represent all of their answers by using just a single number. Scale of 1 to 10, rate math.
But what is the scale? Like, is it easy, hard, fun, unfun?
Enjoyment, overall appreciation, how positive your opinion is on it.
Okay, I will answer this in a few parts because my answer changes depending on the context. For enjoyment, 7, because it's challenging but satisfying when it clicks, but it's like a 2 when you get stuck and you are stuck there for a while. Overall appreciation, 9. I can now see that math is everywhere, and I'm so glad I get to notice that and see all the different places math can be used. Opinion, 7. I like math, but I'm a bit biased. I wouldn't say math is for everyone, but I think everyone can benefit from having good math skills. It translates to other skills like critical thinking and problem solving. My final score, 7 to 8.
We'll go with 8. For those of you who have seen this Bowmass video, and if you haven't yet, you definitely should go check it out immediately. But this is the guy who built the Tesla coil that I showcased in that video. How would you rate math on a scale of 1 to 10?
As an esteemed disciple of Bowmaths, I would absolutely rate math at 10 out of 10.
Good.
Hi, my name's Yard Johannes. I was tutored by Bowmaths, and he asked me to write math on a scale of 1 to 10. And to be completely honest with you, I'd give math a solid 5 out of 10. Because there's certain parts of math that I absolutely despise, but I do love the, remembering formulas from before and trying to use them to figure out a problem. But other than that, when are you going to use math in the real world? Let's be honest.
I would rate math a 10 out of 10 for its applications in day-to-day life, as well as its contributions to early development in critical thinking skills and analysis.
On a scale of 1 to 10, how would you rate mathematics?
Scale of 1 to 10, I'd probably rate it at an 8. And that would be based on a couple things. So in my line of work, use a lot of math for calculating. It's going to sound bland because it won't apply to most jobs, but refunds or even just pricing out projects. The other part is I like to do carpentry, so a lot of math is involved with measurements and how everything can come together. You have a sheet of plywood, basically building a giant puzzle. So where I say 8 instead of 10 is because of my genuine dislike of how I was taught math in high school. I didn't excel at it, so that's why I'd give it an 8.
All right, thank you very much.
Yeah.
So this is the Tired Writer, whose YouTube channel has much less subscribers and success than mine does, as you can see by this comparison on the screen now. So I decided to help the Tired Writer out and maybe share some of my subscribers, which are way more than hers. All right, the Tired Writer. How would you rate math on a scale of 1 to 10?
Look, I am like a calculus god.
Yeah.
But I would have to say 1 out of 10.
1 out of 10.
1 out of 10.
I changed my mind. Don't subscribe to the Tired Writer.
No!
Shiloh, what would you rate math on a scale of 1 to 10? I don't know about you, but I think that was clearly a 10. So how much do you like math on a scale of 1 to 10?
When you talk about math, what are you talking about exactly?
Your experience with it, the subject of it, the concept of mathematics, what you know of it.
I hated algebra in grade, 10, 11, 12. Took logic in university. Swore that I'd never do algebra again. But I actually liked math, like mathematics. So I would say 5.
5?
Yeah, that's probably fair.
On a scale from 1 to 10, I would rate math a 7.
On a scale from 1 to 10, I would rate mathematics a 9 out of 10 because of how satisfying in black and white it is.
So on a scale of 1 to 10, how much do you like math?
Well, I actually did a math minor when I was in university, and going through that, I'd say a 4, maybe 5.
All right, we'll go with the 5.
All right. Can I answer too?
Yeah, go for it, buddy.
Well, I flunked calculus, but numbers are pretty cool, so somewhere between a 2 and a 3.
We'll go with 3.
We'll go with 3.
All right, thanks, guys.
No worries. Today's a great day. No worries. Today's a great day. Today's a great day.
So what's our favorite teacher's opinion on the subject at hand? How do you like math?
I would have answered without all of this, man. Could have just asked.
How do you like math? How do you like math?
10 out of 10, it's so cool.
You heard it here, folks.
Hello everybody, and welcome back to another funky fresh episode of Math. Hope you're all having a lovely day today. Here it's snowing, that's right, at the end of May it's snowing. That's a lot of fun. But in any case, today we are going to be talking about averages and weighted averages. And essentially what these are ways where we can take a group of different values, right? So for example, all the interviews we did at the start there, everyone had some different answers for how they would rate math on a scale of 1 to 10. And even though those answers are different, we can still represent them all somehow with a single number. And that's where average and weighted average come in. So we'll start with the idea of average, and we'll get an idea for what that is really doing. We'll apply it to the group, and then we'll also go into weighted averages. Averages. Just a little heads up. I have a little bit of a wound on my hand right now. Not the nicest to look at, so I'll be wearing gloves for this video. Enjoy. Alright, so the first definition is that the average of two numbers is their sum divided by 2. For example, the average of 4 and 5 is, well, we take their sum, right, 4 plus 5, and then we divide it by 2. And that gives us 9 over 2, which is the same thing as 4.5. So the average of 4 and 5 is 4.5. And so 4.5 is supposed to represent kind of both of these numbers somehow. And so it's kind of intuitive that what we get is the number that's in between 4 and 5, exactly in between 4 and 5, right? Halfway from 4 to 5 lies 4.5. And so the average of these two numbers kind of is like a compromise between the two numbers. And in this way, it represents both of them, even though it's not actually neither of them. So we could consider the average of 9 and 11. So if we add 9 to 11 and then divide it by 2, we're going to get 9 plus 11, which is 20, over 2, which is 10. So 10 is the average of 9 and 11. And once again, this is somewhat intuitive because 10 is exactly halfway between 9 and 11. So the average here is kind of giving us a way to find the number that's in between these two. But what if we want to take the average of more than two numbers? Alright, so here we have that the average of a group of numbers is their sum divided by how many numbers are actually in the group. Okay, so this is analogous with what we saw, right? Here was a group of 2, so we divided by 2. So if we have a bigger group, we just add them up still, and then we divide by how much is in the group. So for example, if I did the average of 4, 5, and 18, I add them all up, 4 plus 5 plus 18, and since I'm doing this with 3 different numbers, I'm going to be dividing by 3. 4 plus 5 is 9, plus 18 is 27 over 3, and 27 divided by 3 is 9. So the average of these 3 numbers is going to be 9. And so that makes sense, it's a fairly simple calculation, but we do kind of lack some of the intuition we had when we were just averaging 2 numbers. 9 isn't really between 4, 5, and 18 anymore. I mean, yes, it lies within 4 to 18, but it's not really halfway between the numbers anymore, and that's because there's more than 2 numbers, right? There's 3 numbers. You can't have something that's halfway between 3 numbers because there's more than 2 sides, basically, right? So we lose a little bit of the intuition that we had with the average of 2 numbers. So what is kind of a way that we can maybe recover a little bit more meaning in this definition? Let's go back to the average of 2 numbers for a second. If I did the average of 6 and 8, well, I would just do 6 plus 8, and since there's 2 numbers, I divide it by 2. 6 plus 8 is 14, 14 divided by 2 is 7. And that makes sense, 7 is halfway between 6 and 8. Okay, but now let's try and use a different perspective on this. And this is where all our work with fractions is really going to come in handy. So I have 6 plus 8 over 2. But I know that I can split this up into 2 fractions, 6 over 2 plus 8 over 2. The reason I know that is I'm just kind of undoing fraction addition, right? If I had these 2 fractions, since they're the same common denominator, I can just add their numerators, and I would get to this 6 plus 8 over that common denominator of 2. So I'm just undoing that, I'm going backwards, and I'm splitting this up into 6 over 2 plus 8 over 2. Now, I'm not just going to say 6 over 2 is 3 and 8 over 2 is 4, even though that's true. I want to do something else here. What I want to do is, I know that 6 over 2, that's the same thing as 6 divided by 2. But if you recall from the video that we did on talking about perspectives on fraction multiplication, we viewed fraction multiplication as having a double action. So recall that if I did 6 times a half, this multiplying by a half had the double action of essentially multiplying by 1, or stretching by 1, and dividing by 2, or compressing by 2, right? And so this 6 divided by 2, we can actually write that as a half times 6, and that essentially represents us kind of dividing the 6 by 2, or compressing it, right? So this is another way that we can represent this quotient right there. And we're going to do the exact same thing with the 8 over 2. 8 over 2 is the same thing as a half times 8. And again, we know that's true. We can even multiply this out, right? This is the same thing as a half times 8 over 1, which becomes 1 times 8 in the numerator, which is 8, and 2 times 1 in the denominator, which is 2. So these are equivalent to each other. But the reason I'm actually splitting it up like this is, notice what we're doing. We're essentially taking 6 and we're taking a piece of it, right? We're taking half of 6. And we're taking 8 and we're taking a piece of it. We're taking half of it. And so essentially, we're taking these pieces of them, right? We're taking 3 and we're taking 4. And then we're combining those pieces back together. And so this 7, in a sense, it was constructed by decomposing the 6 and the 8 and putting those pieces back together. And the important thing is to note is that we took half of 6 and half of 8. And so this half that we took from the 6 and the half that we took from the 8, that adds back up to 1, right? And if you recall from our videos on probabilities, oftentimes we liked it when all of the probabilities added up to 1, because that represented that we had kind of a whole, a completeness, right? So essentially, we're saying, okay, we're splitting 1 up into a half and a half, right? Because that adds up to 1. The first half we're assigning to the 6, so we're going to be essentially taking half of the 6, and then the other half we're assigning to the 8, so we're going to be taking half of the 8, which is the 4, right? And then we're combining these pieces back together, which is going to give us the whole again, but the whole that we're getting is constructed from the piece of the 6 and the piece of the 8, which gives us the 7. So you may think this is a much more complicated way of viewing the average, and it is. It's a lot more in-depth, it's a lot more thorough, but now we're going to be able to apply this to groups of bigger sizes. So let's consider the average of 3, 6, and 18. Alright, so one way we can do this is we just add them up, right? And divide it by 3, because there are 3 numbers in this group. So 3 plus 6 is 9, plus 18 is 27, over 3 is 9. Okay, so 9 is going to be our average. But now what we're going to do is we're going to kind of apply this interpretation to this situation where we have more numbers. So let's consider the 3 plus 6 plus 18 divided by 3. I know I can split this up into 3 over 3 plus 6 over 3 plus 18 over 3, right? It's just that common denominator, so we're just kind of undoing the fraction addition. And we can split this up further into a third times 3, plus a third times 6, plus a third times 18. So what have I done here? Because we have 3 things, we want to split up our whole into 3 different groups. So the way to do that is taking a third, and a third, right? Those are each the same size of piece. And then we're applying the first piece to our first number, to the 3. And we're applying that second piece of the same size to our second number of the 6. And then we're applying that third piece of the same size to our last number, which will then give us a 6. So what we end up getting is that we're equally representing the 3, the 6, and the 18 by assigning them the same size of the whole, right? The whole is split up into 3 equal sized pieces, and each of these numbers get one of those pieces. And so what we end up getting is 9, because 9 is composed of these 3 even shares that all the numbers get. So if we did even something bigger, right, we could do, let's say, the average of 2, 5, 10, 12, and 70. Okay, well, we have 5 pieces here. So one way we could do it is we could add up these 5 numbers and then divide by 5, right? But let's consider the other perspective here. So what we're doing is we have 5 numbers here, right? So each of these numbers we want to give the same weight to, right? So that way they're all kind of represented by this average, which again, that was the goal of the average, right? Getting a number that represents all of these numbers. So if we want to split a whole up into 5 even pieces, each of those pieces will get a size of a fifth, right? So what we'll do is we're going to take a fifth of each of these numbers, and we're going to add that all up. All right, so a fifth times 2, that is going to be 0.4. A fifth times 5, that's going to be 1. A fifth of 10, that's going to be 2. A fifth of 12, that's going to be 2.4. And a fifth of 70, that is going to be 14. So all of these numbers are essentially our scaled down versions of the numbers we started with, but we scaled them down all the same way, right? Because we want it to be the same representation of each of these numbers. And then we just add it all up. So what we end up getting is 0.4 plus 1, so that's 1.4, plus 2 is 3.4, plus 2.4 is 5.8, plus 14 is 19.8. So 19.8, that is going to be the average of 2, 5, 10, 12, and 70. This number represents all of these numbers because it was made by taking even-sized pieces of those numbers. Okay, so now that we understand how averages work, let's apply the average to the actual data that we gathered, to all these interviews, and see what the average score of these people is regarding how much they like math on a scale of 1 to 10. So I've written down all of the numbers that we have here, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different numbers. So that means what we're going to have to do to get the average of this is add up all of these numbers and divide by 13, since that's how many numbers we have. All right, so in the numerator, I'm getting 91 for the sum, and when we divide by 13, we get 7. So that actually worked out really nicely. We got a nice even number. I didn't expect us to get a nice whole number like this without decimals, especially considering we're dividing by 13. Oftentimes, when you divide by 13, it doesn't work out nicely, but we got lucky here. So the average score then was a 7. So that means that if we were to take all this group of people, on average, they would enjoy math as a 7 out of 10. Now, again, it's not true for everyone, right? Some people scored much less than 7. Some people did more than 7. There was actually only one person, Felix, who got 7 as his score. But the average, again, that's just meant to represent the group as a whole, right? Not necessarily each individual member of the group. And again, if we want to interpret our average as what it actually did, we're essentially splitting a whole up into 13 pieces, right? And we're just giving one of those equally sized pieces to each member of this group, and then that number ends up being what the average is. So everyone's number got equally represented.
Weighted averages.
But what if we don't want everyone's number to be equally represented? For example, Shiloh's a dog. Maybe we don't want her number to be represented at all, right? Or I'm a mathematician. I am biased, obviously, so maybe my number should have less weight to it, right? So this is where weighted average comes in. And this allows us to basically make some people's opinions worth more and some people's opinions worth less, or some of the numbers have more impact than some of the other numbers. All right, so weighted average, like the average, it gives us a way to find a number that represents a group of numbers, right? So just like we had before, we found a number that represented the group, but this time we can give some numbers more value than the others. With the original average, everything had the exact same value to it because we split that one up into the same sized pieces. But now some numbers can have more value than others. So to do this, assign a weight. And the weight is essentially a fraction, right? What you're multiplying the number by. So how you're scaling that number. So we assign a weight to each data, to each number, and we must ensure that the weights add up to 1 because we want the whole to be represented. So all of our weights need to add up to the whole so that essentially all of these numbers, we can just take their pieces and those pieces will contribute to a whole, which is our weighted average. All right, so let's try this. So here I have everyone's scores, and I've also given them a bunch of weights. So to start with Bowmaths, myself, I gave myself a weight only of 1 out of 100 because I'm super biased, right? Math is my job, I have a math YouTube channel, I'm teaching you math, so obviously I'm going to get a 10. So maybe we want to eliminate some of that bias and make my score worth a lot less than everyone else's. Also with Shiloh's a dog. I just gave her a score of 10. She didn't actually vote on anything. So to completely eliminate that, we could give her a weight of 0. So her score isn't even going to be counted in these scores, essentially, right? And then with Kyle and Jared, I know these guys, both of them studied math in university, so they're also fairly biased. So maybe we want to give them a little bit less of a weight than the others as well. So I only gave them a weight of 3 out of 100. And then for pretty much everyone else, I gave a weight of 9 out of 100. Maybe they're a little more neutral, they represent more kind of the average population. But for Aiden, I gave him a weight of 21 out of 100 because, well, you saw it, he threatened me with a stick. So I gave his score a little bit more weight. But the key thing here is no matter what I choose for their weights, if I add this all up, what we're going to get is that these will add up to 100. So I encourage you to do that, but the weights will add up to 100 out of 100, which is 1, right? So since the weights add up to 1, all of these numbers that we're going to be taking pieces of, those pieces will add up to a whole, right? So we're going to be constructing a new number that has a little bit of Kyle's, a little bit of Jared's, a really small amount of mine, none of Shiloh's, and then somewhat of a chunk of everyone else's numbers, all kind of fused together to create a number that represents us, but with some people more represented than others. So let's go ahead and actually do this calculation. So if I have 8 times 3 over 100, that's 24 out of 100. And then 10 times 9 out of 100, that's 90 out of 100. 5 times 9 out of 100, that's 45 out of 100. 10 times 9 out of 100, 90 over 100. Alright, so all I did is I just multiplied everyone's weight with what their score was, right? So we're just taking a piece of each of their score. And that gave us these numbers right here. So now all we have to do is add up these numbers and see what we get. And that's going to be our weighted average. So the number that represents all these people that accounts for some people having more valued opinions than others. All right, so when I add everything up, I get 583 out of 100. All right, so we just added this all up. We get 583 over 100, which is the same thing as 5.83. That means the weighted average of these people's ratings of math is now 5.83. So notice that is significantly less than what we had for the average before. And that's because we gave some higher weight to people who maybe didn't like math as much. For example, Aiden, he had a much higher weight and his score was only a 3. And for most of the people whose scores we gave lower weights to, like Kyle, Shiloh, Jared, and myself, we all had higher scores than most of the other people, right? So we gave the higher scores less weight and maybe some of the lower scores more weight. And what that resulted in was a number that represented the group, but represented it in a different way. And that's why we got a different number. So we can play around with making up all kinds of weighted averages by just choosing whose opinion you want to give more value to, right? You may have different reasons for doing that.
Concluding thoughts.
But I hope you found this concept interesting. I think it's a really, really cool idea when you actually break down what an average is actually doing. We use averages all the time in the real world, but we hardly stop to think that what we're actually doing is we're just kind of splicing up these numbers and piecing them back together to get a number that was formed by the pieces of these numbers. And once we understand that, we can really start looking at the details of how we actually split up these numbers and piece them together, and that's what we do through the weighted average. So with all that being said, I'll see you in the next video where we practice these ideas and get more comfortable with them. But until the next video, you have a good one, you stay groovy, and I'll see you in that next video.
Bo Maths.